Arctic winter shock. Rain, flowers, and a new reality. Imagine heading to one of the coldest places on Earth, bracing for biting winds and endless snow, only to find yourself wading through rain puddles and surrounded by flowers. It sounds like a scene from an alternate reality, but this is the Arctic today, a region undergoing changes so profound they're rewriting what we thought we knew about winter. The transformation isn't just surprising, it's alarming, and here's where it gets controversial. What happens when the very essence of a season disappears? Is it still winter if there's no snow? Let's dive into the details. In February 2025, researchers stationed in Svalbard embarked on a mission to study fresh snowfall patterns. They came prepared with layers of thermal gear, heavy-duty gloves, and insulated boots, equipment designed for sub-zero temperatures. But instead of pristine white landscapes, they encountered something entirely different. Rain-soaked ground, exposed tundra dotted with wildflowers, and meltwater pooling at the edges of glaciers. Temperatures soared well above freezing, rendering their cold weather gear utterly unnecessary. The Arctic, once synonymous with relentless frost, was behaving more like a temperate zone. Dr. James Bradley, a leading environmental scientist at Queen Mary University of London and the primary author of a recent commentary published in Nature Communications, recounts his experience vividly. It felt surreal, he says. One moment, you're standing on solid ice, and the next, you're ankle-deep in water at the base of a glacier. The thick blanket of snow that should have covered everything? Gone within days. For Bradley and his team, this wasn't just inconvenient, it was a wake-up call. The research goals, centered around studying freshly fallen snow, were derailed as rainfall dominated the weather during the 2-week expedition. Out of those 14 days, they managed to collect usable snow samples only once. Laura Malares Moncayo, a PhD student collaborating with both Queen Mary University and the Natural History Museum, echoes this sentiment. She explains how the lack of consistent snowfall disrupts the scientific process. Without reliable access to frozen season data, establishing accurate baselines becomes nearly impossible. Moreover, these shifting conditions raise serious questions about the feasibility of conducting winter fieldwork safely. Thin, slushy snow made traversing the terrain difficult, posing risks such as stranded vehicles and limited escape routes if polar bears appeared unexpectedly. These logistical challenges highlight a broader issue. How do scientists adapt to an environment that no longer behaves as expected? But why does any of this matter beyond the realm of academic research? Well, the implications are staggering. Svalbard, located deep within the Arctic Circle, is warming at a rate 6 to 7 times faster than the global average. Its winters are changing even more dramatically, with seasonal temperature increases nearly doubling the annual average. This rapid warming doesn't just alter the landscape, it sets off a chain reaction. Melting permafrost releases trapped greenhouse gases, accelerating global climate change. Microbial activity spikes in newly exposed soils, further contributing to carbon emissions. Meanwhile, wildlife species adapted to extreme cold face uncertain futures as their habitats transform overnight. And this is the part most people miss. Winter warming events aren't isolated incidents anymore. They're becoming routine. Rain falling in the middle of what was once a reliably frozen season creates temporary lakes atop frozen ground, which then drain away, leaving behind barren surfaces primed for biological activity. In some cases, entire regions lose their protective snow cover, exposing fragile ecosystems to unprecedented stressors. These cascading effects ripple outward, impacting not only local flora and fauna, but also human communities dependent on stable Arctic conditions. The urgency of addressing these changes cannot be overstated. According to Dr. Bradley, current climate policies are woefully inadequate for the speed at which the Arctic is evolving. He argues that policymakers need to shift from reactive measures to proactive strategies, recognizing winter as a critical period of vulnerability. Increased investment in monitoring systems and expanded research efforts are essential to understanding and preparing for the future of the Arctic. Yet, despite its importance, winter remains one of the least studied seasons in terms of climate science, leaving significant gaps in our knowledge. So, what does all of this mean for the future? One thing is clear. Traditional approaches to Arctic fieldwork may soon become obsolete. As conditions grow increasingly unpredictable, scientists must rethink how they operate in the field. Will they need new tools, new methods, or entirely new frameworks to continue their work? And what about indigenous communities living in the Arctic, whose lives and livelihoods depend on stable environmental conditions? Can they withstand the pressures of infrastructure instability, disrupted transportation networks, and heightened emergency response needs? Finally, let's consider the bigger picture. Are irreversible changes already underway, as some experts suggest? Could the Arctic reach a tipping point sooner than anticipated, triggering widespread consequences for the rest of the planet? These are weighty questions, and they demand answers. So tell us, do you think enough is being done to address the rapid changes occurring in the Arctic? Or are we moving too slowly to keep up with nature's pace? Share your thoughts in the comments below. We'd love to hear your perspective.